Hello everyone. Today we'll be starting lesson 2 of the programming course. We'll be learning about variables. Now what are variables? Variables are merely quantities that can change. They are normally represented by letters of the English alphabet. A, B and C are often used for constants, while X, Y and Z are often used for varying values or values that we have to find. Now, the same way X marks the spot of treasure, it also marks a value we have to find, right? So, as you can see in maths, very often we use the letter X to represent a quantity that we have to find. Let's look at what variables are in programming. A variable is a named container that holds a value. We have a very nice example here. Imagine that the glass is the variable and the water is the value that it's containing. So here we would say glass is the variable name and the water the variable value. Now when we talk about using variables, we talk about giving them a value. When you give a variable a value, you say that you are assigning a value to that variable. In most languages, we do it in this format. We mention the variable name, we use this equal to sign called the assignment operator, and then we mention the value that we are giving the variable. So we could write the previous example of the glass containing water in this manner, where glass is the variable name, we use the assignment operator, and we mention the value of the variable that the value we want to give the variable, which in this case is water. Now let's talk about changing the values of variables. If I enter a variable name c equal to 0, we have given the variable c the value 0. Then, in the next step of my program, I write c is equal to 1. We would have changed the value of c to 1. I then mention that I'm going to print the value of c. The program would then display the value of c, which in this case would be 1. Now, if I were to write c is equal to c plus 1, then the program would understand that we are increasing the value of c by 1 to 2. Initially, the value of c was 1. We are increasing the value of that value by 1. 1 plus 1 is equal to 2. We then print the value of c again. What do you think will happen? What will the program display as the output? Well, clearly, if the value of c is 2 and we print the value of c, the program will display 2. Let's look at a problem to see how variables can be used. So I've entered in a short diagram which shows how tea is made, where we first drop a tea bag, then pour boiled water, and finally let it cool for a few minutes. We can check how we can use variables here. Let's use three variables: no tea bag, empty cup, and temp. So it should be understood that this sign you see here is called an underscore. In programming, in variable names and in several other cases, we cannot use spaces between words. As such, to make variables easier to read and understand, variable names or different parts of the program, we use these underscores characters to denote different words. That's all this means. Temp is short for temperature. So how can we use variables here? So these are all variables and they all have different values, right? We can consider this no tea bag and empty cup to have the values true and false. So if no tea bag is true, that means there is no tea bag. If it's false, that means there is a tea bag. If empty cup is true, then that means there's nothing inside the cup. We have to pour water. And if empty cup is false, that means we have already poured water. Temperature, we can say, can take the values of hot, warm, cold, and freezing. So with respect to the process of making tea, if no tea bag is true, That is, if we have not yet added a tea bag, then we have to add a tea bag. If empty cup is true, then we have to pour water into the cup. And if the temperature is hot, we have to wait until it changes to warm. So this is just an example of how we can use variables in even an everyday life process. Let's now talk about flowcharts. Flowcharts are diagrams used to show how algorithms work in a simple manner. Let's look at a few components of flowcharts. We have the start or stop component. We have the operational rectangle within which we write operations like c is equal to c plus 1 or n is equal to 1 where n is some other variable or anything. If we have an operation, we use it in this rectangle. We can also mention input and output when the program is meant to take an input or when the program is meant to display output using this parallelogram. If we have to make a decision, for example, if we are checking if a variable fulfills some condition, we use this diamond shaped box. The start stop component is merely used to indicate that a program is starting or it is stopping, as you can see here. So it's very important for us to understand how exactly we make algorithms. So we first need to figure out what exactly the problem is asking from us. Do we need to produce an output or maybe just make a change in memory somewhere, like change the value of a variable? If we have to produce an output, what kind of output must we produce? We then have to check what kind of input is given to us to work with. After that, we identify in rough what exactly we will have to do to the input and what conditions we have to make it fulfill. Finally, we decide what processes to carry out in order to transform the given input to the desired output. So, this is just a few steps to follow when we have a problem to be solved. We need to figure out in rough or in very briefly, we need to figure out what algorithm we have to write to transform the input given to us to the output expected from us. Now let's learn a bit more about operators as well. Arithmetic operators perform mathematical processes on the given input. So that would be, we're already familiar with many of these, with the addition, subtraction, multiplication, and division operators. What we may not be so familiar with is the remainder or modulus operator and the grouping operator. The grouping operator is similar to brackets in the BODMAS rule, where anything within the grouping operator will first be solved before anything outside is solved. The modulus operator returns the remainder of two numbers when the first number is divided by the second. Let's look at this example. 14 mod 5. When 14 is divided by 5, it gives you a quotient of 2 and a remainder of 4. This operator returns the remainder. That will be all that we are covering for today. If you would like to get a hands-on experience with the coding mod with the concepts we have learned so far, then please do check our website thinkverse.in, where the full presentation, the full course, and all the coding modules are included.